Sheet J, question 3. Starting off with part A, we want the amount of time taken for the money to double. So if the amount of money was originally £5,000, that means we're expecting it to be £10,000. So let's substitute that A in for the amount of money. Okay, I'm trying to get into this bit here. So let's divide both sides by 5,000, leaves us 2. And n is up as a power, so let's log both sides. You might have chosen to learn it, and that's fine if you did. So you might have done ln 2 equals ln 1.03 to the n. Then, of course, you could bring that n down the front, so I've got ln 2 equals n ln 1.03, and dividing both sides by ln 1.03 will give you the same answer there. So you would get n equals ln 2 over ln 1.03. If you chose to do log both sides but take logs to the base 1.03, that gives you the same. It's 23.5 years to 3 significant figures there. Okay, part B wants to know the rate of increase. The rate means that we need to be differentiating with respect to the time, which is n, a number of years. Differentiating the left-hand side, we just get dA by dN. That's not so tricky. Don't worry about the 5,000 for a second. Differentiating 1.03 to the n, you may not know how to do. So there's two different things we can do here. You might know the standard result by heart, that is if y equals a to the power x. When I differentiate that, I get ln. I get ln a multiplied by a to the x. So in this case, we'd have ln 1.03 times 1.03 to the n. So that's one option if you just know the standard result. Sometimes you actually have to show it. If you have to show it, there's a thing in the formula booklet that we could start off using that would help us. That would be, what colours can distinguish? In the formula booklet, it tells you that a to the x could be rewritten as e to the x times ln a. And that's the standard result in the formula booklet you can use for free. Now, if you decide to differentiate that, so in this case 1.03 to the n would be e to the n times ln of 1.03. If you decided to differentiate that, when you're differentiating e, the coefficient of x, or in this case n, comes down to the front. So that would be ln 1.03 times e to the n ln 1.03. I'm rearranging this, or just using this bit of information here. That's 1.03 to the n. So that's ln 1.03 times 1.03 to the n. Either way, that's how you're differentiating it. So a went to dA by dN, 5,000 just stays out because it's a coefficient, and we've just discovered that 1.03 to the n differentiates to this. And it wants to know the rate of increase of the bank balance after 4 years, so n is 4. So let's substitute 4 in. So just replacing n with 4. Pop it all into a calculator, you get 166 to 3 significant figures. Looking at the unit, that was the change in the amount of money over the time, because it's dA by dN, so that's £166 per year that it's increasing by.